Paper 2 is probably the most talked about challenge in this year's picoCTF. A few days ago, I showed you how a fake GitHub solve actually got people banned. But today, we are doing the real thing. I'm Kat, and this is picoCTF 2026. We are going to solve paper 2 from scratch, entirely from the command line with just curl, a text editor, and a very unexpected exploit chain. A piece of paper is a blank canvas. What do you want on yours? And then we have the source code, just a tar file. So let's grab that. After grabbing the tar file and extracting it, I've opened everything in a text editor. Let's see what we have to work with. So there's a barn file, and if you look over here, they are using also Puppeteer. Nothing else, I don't think, interesting over here. Yeah, just dependencies and whatnot. So let's take a look at the Docker Compose. They install Redis. And also, this is interesting actually. So they are downloading the Debian for Google Chrome, and then they are installing Google Chrome in that container. So we do have Google Chrome as a browser, like the full browser, available to us. And then they run index.typescript. So let's take a look at that. This is probably the most interesting bit. So they create a certificate authority over here, and they create a folder for managed policies, and then they create a policy inside that folder. They start the Redis client. So here a secret is being generated, 16 bytes long. That is then converted to hex. They use Puppeteer to launch Google Chrome. And with some JS flags, now expose jitless. Okay, so basically just very, very slow JavaScript. Headless, true. And this is the important bit here. We see that they are setting the cookie named secret with the calculated value from up here, right? So that value goes in here. Okay, and then, quite important, the security same site is strict, so we can only read the cookie from the same site it was generated as. And over here, we store the secret in Redis with an expiration time of 60 seconds. And so we have 1 minute. And then once it's done doing that, it closes the browser, removes the folder, removes the secret. So after 1 minute, that cookie is gone. This is the most interesting bit here. So script source none means JavaScript is completely disabled. So the content security policy prevents running any sort of JavaScript on any pages on that website. Now we have the browse defined, and we see the root is just showing a form that allows us to upload files. Okay, so we can upload files on the server, and then it hits this endpoint when we post. So that form goes here. It increments the ID and stores it into Redis with a 10-minute expiration date, right? So we can upload random files to Redis and they will expire in 10 minutes. And then we get a redirect response with the new ID. So we have a way to exfiltrate that ID information. And so now we have a URL on the server with content that we control. And then this ties nicely into this endpoint over here, which gets the ID we sent from Redis, right? Before it was stored in Redis. So now it pulls that information and basically sends back the file we sent. Now that bit over here, I feel it's important. So it looks up the cookies in the browser with the secret, and if none is found, it just produces a random data, and then the payload is injected right into the body. So the body will be a CSS selector over here and also injected in the main body of the HTML. The flag endpoint, which it takes a secret parameter on the command line and it calls it guess. And then it takes the secret from Redis, but do note here the getDel, meaning it is retrieved from Redis and deleted once it's retrieved. So you can't try it out, you can't brute force the secret. And if there is no secret, presumably because it was already deleted, it sends nice try. If the secret doesn't match what we sent, it just sends wrong. If the secret matches our guess, it reads the flag from the environment, and we have one shot at this. Otherwise, we have to restart the instance. And then finally, we have the endpoint visit ID, which looks in Redis if the browser is open. If it's open, prints an error message. Otherwise, gets the request ID, right? The ID here. It tells the browser, so that redirects Chrome to this URL, meaning we can upload files with whatever content we want and then trigger Chrome on the server to display those files. We won't be able to see the output because the browser is running in headless mode, as we saw, but at least we can get it to load and render the document on the server side. So here's what Paper 2 gives us. We can upload files and a bot will open them in a real browser. That bot has a secret stored in a cookie, and our goal is to steal it and send it back to the server to get the flag. The application uses a strict content security policy. JavaScript is completely disabled. No script, no fetch, nothing. So we can't just grab the secret and send it out. But there are two tiny cracks in the security that we are going to exploit. The secret endpoint reflects the secret directly into the page, as we saw, both as text and as an attribute on the body tag. And it also lets us inject arbitrary HTML or other file types that we control right next to where that tag is injected. So now we have a weird situation. We can read the secret, but we can't send it anywhere. Or can we? So first, how do we actually read the secret? this is where things get a bit unusual. Instead of JavaScript, which we know is blocked, we're going to use XSLT, which is basically a transformation language that browsers can run on XML. The important part is that XSLT has a function called document, which lets us fetch another page and read data from it. So we can write something like this, and that fetches the secret endpoint in the same origin, which is important as we saw because of the security restrictions. And since the secret is stored as an attribute on the body tag, we can extract it with something like this. And so with that in mind, our first payload looks something like this. And so this embeds an iframe into the HTML. And in that iframe, we are going to request a document, and we are going to append the secret. So this is the first part. So if we can't send the secret from the page, we need something else that can. And this is where the second exploit comes in. When the browser opens a PDF file, it doesn't render it as a normal web page. It uses a completely different engine, the built-in PDF viewer. And that viewer supports its own form of JavaScript. So even though the page on the website blocks JavaScript with the content security policy we saw, the PDF can still execute JavaScript code. This is not the same JavaScript that runs in the browser. It's a completely separate execution environment. Inside the PDF, we can access its own URL using this .url and then send it out using a function like submit_for in JavaScript. So the trick is we take the secret we extracted with XSLT and we place it in the URL of the PDF. Then when the PDF opens, it reads its own URL, grabs that fragment, and sends it to our server. So now let's put all that in practice. Here's a minimal version of the idea. The PDF uses a two-step trigger. Open action sets a form field value. Over here, this is the timeout. And then we have the form handler performing the actual exfiltration and calling our URL. With both files in place, we need one last piece of the puzzle, a place for the PDF to send the secret to. And I want that place to be running on my machine. To capture the secret, we'll spin up a tiny web server locally on my computer. Now, the problem is the server is running on localhost, right? The bot can't reach it. I could open ports, configure HTTPS, and deal with getting certificates. Or I can just use Cloudflare tunnels. We get a public HTTPS URL pointing straight to our machine. Now let's put everything together. So we'll start netcat on our local machine. And we set the port to listen 5000 and we want it to keep running. And so now we have a listener on our local machine that will act as our web server. Let's open a new terminal. And now we'll use Cloudflare to start a tunnel to this tiny server that we have. Tunnel, and the URL is going to be HTTP localhost on port 5000. And if we did everything correctly, it's going to request a new tunnel. And if you take a look over here, we have the URL of our server that is on HTTPS. So now we grab the tunnel IP and going back to our text editor, we have to place this here. and save this. Now we are going to go and launch our instance. So this is the endpoint we are being given. And so going back into the terminal, we are going to open a new window over here. And we have to upload the PDF file. So curl -k-f, and then file is exploit PDF. That's how we named it. And then the type of the file is application PDF. And we are going to paste the target and append the upload endpoint. So we get the first ID we needed. So if we go back here and we switch to the XML, we have to put 1 here, which is the ID we got. Now the next step, we have to upload the XML, which is quite similar, except here is going to be, the type is going to be text XML, and then instead of exploit PDF is going to be exploit XML. Okay? And we take a note of the 2 at the end of that URL. We are on the last step of the exploit now. Don't blink or you'll miss it. We'll trigger the bot to visit our XML. And so we do curl -k to ignore the certificate errors. And we see the visiting message. Keep an eye on the top window. And so you see the secret over here. And now we do secret equals, and then we grab that. Right, so we set the secret. And now we do curl -k. And then we need the URL. And we have to specify the secret equals secret. So we grab the flag, we go over here, we paste it, and we submit it, and there you have it. This challenge wasn't about breaking one thing. It was about chaining the right exploits together. We used XSLT to read the secret, a PDF to send it, and a tunnel to catch it on our own computer. So using just a text editor and the right ideas. Thanks for watching. If you've enjoyed this, give it a like. It really helps me out. If you'd like to get notified in the future whenever I post new solves, hit that subscribe button. I will see you on the next one. Bye bye.